Welcome. My name is Dennis Hanks, and this presentation will be on how to determine schedule contingency by modeling schedule uncertainty. The basic tools that we're going to use here is Oracle Primavera Risk Analysis version 8.7.4. And many of the schedules that you'll see here are developed with Primavera P6 8.2. Now before we get started, I want to set some ground rules. The most important of which is that the schedule that we're going to use is well crafted. It has passed both the P6 schedule log and the Primavera schedule check. And that means that basically it only has two open ends. It has no hard constraints, and it has no negative float. And further, that it basically captures all of the time variable activities in the project. Another point here is that the durations are determined rationally, and that means that they came from some point other than the planner schedule. That we can point to how they were developed, and that it is a resource loaded schedule so that we have crew sizes against these durations. And the third point, which is just more a caveat, something to be aware of, is that it's probably foolhardy to undertake this without the cooperation and understanding of the project team. And there may be members within the group that are more cooperative than others. And those that are less cooperative, you'll want to spend a little more time with to get their consent. And so that's what the time is about. You'll want to spend as much time as you can to do as good a job as possible. That seems kind of trite and like a truism, but many times we're asked to do a schedule risk analysis with extreme time duress, and I would caution you to resist that as much as possible, or at least to educate the people involved that it will take some time. This is not a cookie cutter exercise. So why is it important to model schedule uncertainty? And the point there is that the durations that we develop from the estimate or whatever, we know are not exact, that they embrace some uncertainty. And the analogy here, of course, is your daily commute. And generally that takes you 30 minutes. And sometimes you've done it in as little as 20, and sometimes it's taken you as long as an hour. And that's kind of the uncertainty there. You don't know that it's going to take you 30 minutes. But if you know that it could take you more than that, you make sure that you have some time on either side, or not on either side, but you understand the nature of your commute. And so the key here is that knowledge is power. The more we understand about our schedule, and the schedule is nothing but a model, is the more powerful we are in dealing with that knowledge. So the important thing here is that we're modeling uncertainty so that we are more prepared for uncertainty. Now, this uncertainty is oftentimes called a risk, and I like to make a distinction between risk events and uncertainty factors, or it's called risk factors. And what we've got here, a risk is essentially an event that may or may not happen, and it's a discrete event. It's a hurricane to strike, it's receiving or not receiving a permit. And this is usually captured in the risk register and becomes part of the risk management regime. There are some times when you would run risk events within a schedule, but I would oppose that. I think that risk events can be dealt best with running either what if reflections or what if special schedules that deal with the risk, and then you can deal with the the likelihood of occurrence, but what you really want to know, because many of these things like hurricanes, you don't know when they're going to happen or how much the impact is going to be. And so it's more difficult to model than you would expect. I tried to do hurricane modeling and did not work out very well. So what we're going to be concerned with here are what are generally called risk factors. And in my mind, they're more situational than long-term, and they generally impact productivity. And so that's going to be things like congestion, and it's going to be the training and qualification of your labor. Those things that really do impact productivity, and these are best captured in the schedule. Now, uncertainty has been with us forever, since the Egyptians built the pyramids or the Romans built their roads. But nobody has had a way of really modeling it. And the only thing that we've had was the old PERT expected duration equation, and this comes back of I believe 1952. And all we're saying is that we're going to have a 3-point estimate on our duration. We're going to have an optimistic duration, meaning that was our 20 minutes. We generally can get to work in 20, or not generally, but there are times when we get to work in 20 minutes. Pessimistic, sometimes it takes us 60 minutes. And then there is our estimated value, which is the 30 minutes. So the equation here is going to be basically 20 plus 120 plus 60 divided by 6. Now the problem here is that E is the only value that was objectively determined, and this assumes that it came from an estimate as opposed to what we generally think is going to happen. So just some working definitions, and these are my definitions. And so for me, uncertainty is the range of possible durations that an activity may need. And again, that goes back to the 20 to the 60. And contingency is going to be the additional time and monies needed to achieve stated project objectives within acceptable exposure. And this, again, is going to be the difference between the forecast that we develop and the deterministic that came out of the P6 schedule. Now, what we're really after here now is to develop these 3-point estimates for each activity. And I really do want to stress that these are guesstimates, where even though we do have an estimated value, none of this is really that firm. But this is critical. If we get it wrong here, if we get our duration or our ranges wrong, everything that we do is going to be useless. It will not make any sense. And for me, I have 3 different methodologies, techniques, tools that I use, and these tools are usually determined by the size of the schedule. So in smaller schedules, 100 and 300, say FEL 1 and FEL 2 schedules, I use direct determination, and we'll have an example of that. And each one of the activities within these smaller schedules is generally independent, that whatever activity is being performed is not generally impacted by another activity. Now, when we get more complex, we get in their mid-range, say 300 to 1,000, I use percentages. And that's just because I'm dealing with more activities. And it could be a mix, of course. So we could still have the direct determination, or we could have something depending on a group of activities. And then, of course, we have the big one, which is what we should really be talking about here, which is the 1,000 to 3,000 activities. And this is generally be the schedule developed from a class 3 or better estimate. And if it's any activity that uses the same unit rate, in my opinion, is 100% correlated. And again, we want to make sure that these ranges are you're only using P10 and P90 values. So going back to our analogy of 20, 60, and 90, We don't want any value less than the P10, which is our 20 minutes. So yeah, maybe there was one time when there was no traffic and we hit all of the lights and we were able to do it in 15 minutes. That occasion is so rare as to be unuseful. And the same thing with the P90. There may have been some times when we were not able to get to work at all. But we don't want to include any of these extremes in our analysis. So this is the end of part one. And I hope I've set the stage for what we're going to do in part two, which is going to be to show you kind of examples of all of these. Thank you.